varying by year. I mean, I'm just wondering why the model is so easily adapt to different sizes if there are an size distribution in the data.
Well, the parameters of the growth curve are not necessarily time varying. I mean, the growth is following cohorts, and the default is that all cohorts have the same growth parameters. But you certainly can have any of those growth parameters be time varying. So that is certainly an option to have. But again, you're greatly adding the complexity because you're now requiring the model to have to recompute the age length key repeatedly, especially in a model formulation like this, where you basically are simulating, so you're needing to recalculate all those age length keys. Maybe I'm not quite getting your question about this.
So I'm coming at this from the Gadget side. So in Gadget, we have the growth formulation is such that you have a form pattern curve or something like a growth function that gives you the expected growth update for a given length group.
Okay.
And then this growth update is dispersed using a beta binomial distribution around that mean growth update.
So are you getting age from length or length from age? In synthesis, we're getting length from age. So we have a von Bertalanffy, or with age-specific K in this case, growth curve that is giving us mean length at age. So at a particular point in time for that age, we can know the normal distribution of length at age, and then we can parse that normal distribution into the length bin structure that has been established for the model. So we're simply creating a histogram out of that distribution for length at age, and then comparing it bin by bin to the length data.
Yeah, the Gadget model is actually, you have an age length matrix for every time step. So you subtract numbers from.
Yeah. That's a difference. And so, because there you are propagating from one age length key to the next age length key through some length-based survivorship, correct? That is not something you can do inside of synthesis, but there is an approximation in synthesis that I think gets you a large fraction of the way towards having that capability. And that is by invoking a concept we call platoons. And it basically takes the growth curve and subdivides that one normal distribution of length at age into, say, 5 distributions that would sum up to be a close approximation to that original single distribution. But you now essentially have a fast-growing cohort, a middle-growing cohort, slow-growing cohort. And so each of them experiences their own fishing mortality based upon the size selectivity of the fishery. So you can end up achieving higher fishing mortality on the fast-growing fish, lower survivorship of the fast-growing fish. And so you get a large fraction of the way towards having that full age length survivorship capability, but you're only having to track, say, 5 cohorts. So you're tracking 5 cohorts rather than 1 cohort. So it definitely is more and it's slower. It's almost linear in how much slower it is, but you do achieve that length survivorship. And then we have a project going that is looking at how well this works with data that were generated by an individual-based model. And it's looking quite promising that even though the data clearly show that the largest fish are dying off, the model, by using platoons, is able to recreate the L infinity that is inherently there in the population, even though it's been masked largely by the length survivorship.
All right, I'm gonna just jump in here, guys. If there's more, the good conversation, if there's more, just
New workshop.
maybe, yeah, that's right. Yeah. We are at the end here. We're at the ending point. So I just wanted to say thanks to everybody, especially the presenters, as well as everybody. Today was our longest webinar, so I really appreciate everybody's patience and attention today. I wanted to note that the presentations that were given today, as well as the recording, will be posted online, or I'll send out an email as well as posted on the GitHub, probably within a day or two. And I think that's about it for today. So everybody have a great rest of your week, the rest of your month, and we hope to see everybody in early January for our 4th and final webinar. Thanks so much.
Thanks, everybody.
Thanks, Arnaud, and everyone.
Merry
Thanks,
Christmas.
everyone.
Bye-bye.
Thank you, everyone. Bye-bye.